Hello students, let's move to the next type of solid, which is pyramids. So in case of prisms, we have seen one top face, one bottom face and 6 lateral surfaces, which is of the shape of the rectangle. In case of pyramid, it has got only the base, no top face. Instead of that, this point is called as apex. These are called as slant edges. These are base edges. So totally 6 slant edges, 6 base edges, and this is nothing but, and this is slant triangular faces. So this point is apex. So in the top view, you'll be able to see all the lines, the slant edges is going to be in the thick lines. So whereas in case of prism, we're going to have the top face. Even if you're going to keep this one in the wireframe, this will be just hexagon. So that is the difference between the pyramid and prism. So in case of pyramid, all the slant edges, whatever we are going to draw, is going to be in thick lines. So let's move to the problem. So this hexagonal pyramid, 25 sides of base and 50 axis length, rest on HP on one of its edges of the base, which is inclined to VP at 30 degrees. So which is inclined to VP indicates that anything which is going to be inclination with respect to VP is going to be for the third step. Here we need to, whenever the solid is on HP, second step, we need to see the inclination with respect to HP. So let's move to the questions. So this is the first step, hexagonal pyramid. So you need to remember this. Do not get confused with the pyramid and prism. So if you have any confusion, so this is prism and this is pyramid. So you can just blindly remember in this way. And if I'm going to draw a line below this, so this is nothing but, which is going to be the prism. In case of pyramid, so this Y is there, so you can see that this is apex. So just as the blind method. So let's move to the problem. Here we need to go to hexagon. Already you know how to construct the hexagon, so I don't want to teach again how to draw the hexagon. If you want, you can just refer my previous video of the hexagonal prism. So this is the pyramid top view. So if I'm going to draw only hexagon, that becomes the top view of the prism. So which is going to be like this. So we need to make all these slant edges going to be in the thick lines. So I'm going to like this. I'll be drawing these lines in the thick line. In case of prism, we used to draw these diagonals in thin lines to find the construction line. Here it is going to be pyramid. So here let's move to this. In case of prism, we got the A point here, A1 here, B, C, D, E, B1, C1, D1, E1 and F1. In case of pyramid, there is no top face. So directly we are going to call this point as A, B, C, D, E and F. So this point we are going to call anyway the apex point, which is going to be O. So here the axis point we are going to call this as O1. So here let's keep this annotation. So this point is A, this is B, this point is C, this point is D, and this point is E, and this point is F. So let's draw its projection lines. So all this is going to be in thin lines. So here I'm going to need to draw the axis line. So axis length is going to be 50. So I'm going to draw this 50. So outer boundary is going to be in thick lines. So I'm going to join this. So just join this. Now I need to see the outer boundary, whatever I drawn is going to be thick lines. So next thing is I am going to draw imaginary horizontal line. This is just for your reference. So below this point, which is nothing but the apex point, this is going to be the first nearest point, second nearest point is A and C. So line joining A, B should be in thick lines. So here when I'm going to be keeping it like this, so this slant edge is going to be dominating the axis line. So front view, so I'll be able to see the outer boundary. Also this edge is going to be seen. Even if I'm going to keep it on the wireframe, this edge is visible. So the same thing, we are going to be drawing this line as in the thick lines. If it is resting it on corner, we can able to see the axis, but this is on the edge. That is the reason why this edge is going to be dominating. So we are going to keep the annotations. So this point is, the apex point is O, and base O1 is not seen. Here O dash is nothing but the apex point, but O1 dash is not visible. So this point is A dash is seen, but F dash is not seen. This point is, this is nothing but the nearest point. So B dash to O dash, B dash to A, B to C, B to O is going to be thick line. So this is B dash, but E dash is not seen. This point is C dash, but D dash is not seen. So now I'm going to keep the annotations nearer to the point. So as soon as we're going to create the solid, the first thing is we need to give its dimensions. So this is the 25 side, so this is just the reference. I'm going to remove this. So this is going to be 25, axis length is 50. So one of its edges of the base, so it is resting on one of the edges of the base is nothing but DC. So now I'll just make this one. So one of the edges means I have to keep the edge on the right side. So next step is, which is inclined VP. So this is the third step. Draw the projection of the axis when the axis is inclined at 40 degrees with respect to HP. So this is, so this axis length I'm going to able to maintain it as 40, but I cannot able to take this measurement and cut which is the point to locate it is going to be difficult. So what we need to do is, we need to make this front view where the axis is going to be inclined 40 degrees. So and one more thing is, whatever we are going to be solving is going to be the regular solid where this axis is exactly perpendicular to the space. So what I'll be doing while constructing is, I'm going to be drawing the base first, because I cannot draw this axis point here, then cutting the point where, and also I need to make this one perpendicular is not easy. So instead of that, what I do is I'm going to draw a line which is going to be the length. I'll just measure this distance, which is going to be 43.3. So I'll take this point 43.3. so this is the base. So I'll take this measurement, which is the slant length is measurement is 54.49. so I'll cut an arc 54.49. So now I've just drawn a line. Now this is exactly the midpoint. So you can just take this measurement and cut an arc and draw this line. So from here I'm going to draw this line. So now I said that the angle between this and the base should be 90 degrees. So this is done, and as per the question, what we need to do is we need to make the axis which is going to be inclined at 40 degrees. I did not tell you what angle I have taken, so this angle should be 40 degrees. So this is achieved when I'm going to be drawing this triangle. This is the triangle. The sum of this, all the three adjacent sides, is going to be 180. So this is 40 degrees. That means this to this I need to maintain 90 degrees. So that means this base should be tilted at an angle 50 degrees. So that is the reason initially I am going to draw this base which is going to be inclined at 50 degrees and equal to this 43.3 length. So this angle I'm going to draw 50 degrees, 43.3. Then from here I'm going to take this length measurement. From here I'm going to cut, from here cut it. I'm going to draw this triangle. After drawing it, I'll take this measurement from C dash to O1 dash and cut an arc. Then I'm going to draw it and extend. I'm going to check it whether this 40 degrees with respect to HP is achieved or not. If it is achieved, then what we've done is correct. So whenever we are going to be drawing to achieve this 40 degrees, some students we're going to draw it and draw somewhere else. It is not going to be touching the XY line. It is going to be like the freely suspended problem. So this is very important while constructing the pyramid. Now we have just kept it like this. Now I need to project its top view. So the second step is like this. So where it is going to be resting it on edges of the base. Then we have inclined the axis 40 degrees. That means this base is going to be inclined 50 degrees with respect to HP. So now how it is going to be seen in its top view, we'll be able to see three triangular faces. So base is not visible. So here also the same way I'll be just projecting like how we projected in case of the prisms. So project these lines. So this is point O. So this is O dash apex point. I've just joined it. Let's move to the projections of this point A. A is still this point. Then this point is B and E. So B is being projected till here. Then C till this point. So here you can see that the outer boundary of the solid is visible. So it is going to be in thick lines. So I'm going to make the outer boundary of the solid should be thick lines. So before that I'm going to keep the annotations. So I kept all the annotations. So now let's join the outer boundary of the solid A to B to this point O and to this point E and to this point F and to the A. So this is the outer boundary of the solid. Now we need to see the nearest point for the observer. Now we need to see the nearest point for the observer. So it is, if I'm going to see the nearest point is observer is O. So O to A, B, C, D, all the edges is going to be visible, which is not going to be happening for the pyramid. So you need to ignore the apex point. So you need to see the base for the pyramid. So nearest point for an observer is A and F. So line joining A and F should be in thick line. So A to B is already thick line which comes at the outer boundary. A to F is a thick line which is already outer boundary. Remaining is A to O point. So A to B, A to O, A to F is thick lines. Similarly F point, F to A, F to E, F to O is remaining. So this is what we are going to be able to see three triangular faces in the top view. So this is what we are going to be seeing it here. Then we need to see the hidden edges. The farthest point for an observer is C dash D dash. So line joining C dash D dash should be in hidden lines. So C is joining to where? C to O, C to B, C to D. So C to B is hidden line, C to O is hidden line, and C to D point is also hidden line. D to E is also hidden line. D to O is hidden line. Now line joining D point is not seen. We are going to keep it inside the bracket. Similarly, line joining C is not visible, so I'm going to keep it inside the bracket. So at last I'm going to be projecting the access point, that is, so this is the O point. So from here this should be in axis 9. So O1, you can see that O1 is nothing but comes under the base. O1 is not going to be visible, so that is what here. The farthest point is nothing but which is going to be resting it on HP is the farthest point. So this one, even the base line joining this and this is not seen in the top view. So next step is we need to see is so now you can see that we need to see one of the edges of the base which is inclined to VP at 30 degrees. So this is similar to the a square prism problem which we have solved in the previous class, where this resting edge has been inclined with respect to VP. So this one is prism, this one is pyramid. So now already you know how to construct it. So I'm going to draw this 30 degrees line first. So make sure you're going to keep sufficient space for this problem. So this is nothing but this solid. So this is how we are going to be inclining it. So this is the resting edge which is inclined 40 degrees with respect to VP. So in front we will be able to see like this, and we are going to be in the top view, it is going to be seen like this. So important thing is I can tilt either this way or this way, where I can going to be keeping the apex nearer to the observer. So whereas in this problem I have kept the base nearer to the observer. So here I'll be taking this distance D to C which is equals to 25. So I'm just going to be drawing a line which is going to be inclined 30 degrees. So I just drawn a line. So it should be a construction line, just showing it as a reference. So this point, I'll just draw one of these points, horizontal line, which is just to show the angle. So this should be in thin lines because it is a construction line. So I need to show the angle from this point is 30 degrees. Now I need to find the distance from D to C, which is equals to 25. I'll be cutting an arc. Then I'll be taking the distance from D to E, which will be equal to C to B. So from here cut an arc, then take the distance from C to E. Similarly, D to B will be equal, so from here I'll cut an arc, from here cut an arc, then I'm going to take the C to F, then D to A, then C to A, and this point. We are going to create the hexagon first. So I have just drawn the hexagon first. So next thing is I'm going to take the distance from C to this axis point, which is equals to 12.5. So from here I just take the distance, cut an arc, from here 12.5. So from here I'll be just drawing the axis line. So I'll trim this. Now I'm going to take the distance from this point to, I'll cut an arc, then I'm going to join it accordingly. So this is what it is going to look after drawing. When you're going to draw it, make sure these edges and these edges is going to be parallel, and this edge and this edge is going to be this edge is going to be equal and parallel, this edge and this edge is equal and parallel, so then the pyramid is going to be proper. So now we are going to be projecting to draw the front view. So this point is O point, so first from here project it. Similarly, so this line should be a projection line, not the locus line, so I'll trim the extra line. So from here I'll just go to the point A point, this point is till this point, so go for annotation by annotation. So this point is A is still here, go for the point B, B is till this point, then go to the point C which is at the base, then D, you're going to draw a line, E point is still this point, F point is still here. So I'm going to rub the excess line. Next thing is we are going to write its annotations. So this is what it is going to look after writing the annotations. Now I need to join the outer boundary of the solid. So here go to the point F to O, so this B is outer boundary, this C is outer boundary, to D is outer boundary. Now I need to see the nearest point for an observer. So when I'm going to see from here, so this is the axis point, middle point, so this is nothing but extra, I'll just rub it. So this is a O1 point, so this is A, B, C, D, E. The first nearest point for an observer is A, then B, then F. So all this A, B, F should be drawn in thick lines. So I said in case of pyramid we are going to see only the base, we are not going to consider farthest point as the apex point. Here we are not going to consider apex as the nearest, here apex is not the farthest. So let me consider by joining the visible edges. So A is joining to O, so A to O, A to B, A to F, A to F, A to B. Now the second nearest point is B, B is joining to C, B to A, B to O. So B to C, B to A, B to O is already made the thick lines. Then F, F to A, E, O. Similarly F, E, A, O is in thick lines. The farthest point is, the first farthest point is D, then so this is the first farthest point, first farthest point is D, second farthest is E, and the third farthest point is C, which is above this axis point. So we are going to make these lines in thick lines. So we are going to make thick dash type line. So first thing is first farthest D point, so D to O is dash, D to C is comes under outer boundary, D to E comes under the outer boundary. The next farthest point is E, so E to F, E to D is already outer boundary, remaining is E to O. Next is C point, C to O. So at last I am going to project the axis point. So this should be drawn. Now this point is nothing but O1. So O1 is visible because all the faces of the bottom face is visible. A dash, B dash, C dash, D dash, E dash, F dash is seen. So this is the exactly what we are going to be seeing in the solids. The same thing is here. So this is very simple compared to the hexagonal prism. So important thing is it is resting it on edge on HP. So this is resting it on edge. So edge on HP is nothing but SP1. So this is resting it on edge. This is nothing but DC is resting it on edge, and edge should be right side in case of solids. So on edge on which is we are going to consider as SP1 simple position 1. So earlier it was mentioned as SP2 by mistake because I copied from the previous slide. So this is the resting it on edges DC. Then the axis should be inclined 40 degrees. So to make it 40 degrees, we are going to incline the base 50 degrees. We are going to get the top view by not considering the apex point. We are going to consider only the base. Here we are going to project this. Again, we are not going to consider apex as the farthest point. Instead of that, the base point, which is nothing but D, is going to consider. This is a construction line. I'm not going to retain it. This is just for the understanding purpose. So this point is O1. Hope you understood and have a good day.